Hi everyone, welcome back. Today, let us discuss the most frequently asked question in the interviews. How do you design a software system for a given problem? Let us consider an example, that is chess game. So this complete video builds up confidence in you in designing software system for any given problem. So how do you design a software system for a chess game? So before discussing further, let us see what are the requirements of the proposed software system. It should be possible to set the initial positions of all the pieces in the appropriate slots on the chessboard. And it should allow the players to make the valid movements based on the rules of the game. That means it has to restrict the player to make invalid movements. It should allow the player to capture one or more pieces of the opposite player based on the standard rules of the game. It should also allow to check the king of the opponent player so that the other player wins the game. So as per the standard rules of the game, each player will be having one king, one queen, two rooks, two bishop, two knights, and 8 pawns. This is the requirement of the proposed software system. So let us use object-oriented analysis and design to come up with the software design or the system design. So what is OOAD? So OOAD, as per OOAD, for a given problem statement, first we need to analyze and identify all the objects in the problem domain one by one. Once you identify the objects, it should be possible to identify the fields and the behavior of each and every object and the relationship between the objects. After that, we need to group the similar objects into a class so that we will get a number of classes. Next, we need to identify the relationship between the classes, whether it is inheritance, composition, aggregation, cardinality. Do we need to add any other classes which are not covered in the object, etc. And finally, we need to develop the visual model for the software system using UML, that is Unified Modeling Language. As known, top-down approach is used to design procedural language software system. But for object-oriented languages, we use bottom-up approach. So what are the advantages of object-oriented languages or OOAD design? Is modularity, reusability, either through composition or aggregation or inheritance or whichever. And the one more advantage is polymorphism. So let us start identifying the objects in the problem domain. So in this game, the first object, which is very clearly for us, is the chessboard. The chessboard itself can be considered as an object. Next, each slot, the slot can be either black or it can be white. So each slot is an object. So 8 by 8, that means we have 64 slot objects. Then each piece is an object. For example, king of one player is an object. King of another player is another object. Then queen of one player is an object. Similarly, pawns, rooks, bishop, all these pieces, each one of them are objects. So let us see the list of objects which we have just identified in our domain. Chessboard itself is an object, and all these slots S1 to S64, each one of them is one object. Then the kings K1, K2 are objects, Q1, Q2, and bishops, rooks, knights, pawns, etc. All these are the objects. As already known, every object has data associated with it and the behavior associated with it. For example, if you take the chessboard object, the data is nothing but all the slot objects. The chessboard has all this as the data member, all the slot objects. And what is the behavior of the chessboard? First, you need to initialize the game. That means you need to place all the pieces in the initial position. So that is one behavior which is required. The other is display. That means you should be in a position to display all the pieces and its position at any time during the game. Okay. Then slot object. The slot object, what are the data members? Means a slot object, one of the data member is to identify whether it is white slot or black slot. Another is a slot can have any piece. It can be a king, it can be a queen, it can be a bishop, it can be a pawn. So that is also one data member of the slot. Next, the next is the other objects like pawn, king, queen, etc. So each one can have the name, and there can be other fields like what should be the movement of the direction and how many steps it can move based on the specific piece. And what is the behavior which need to be exposed from these objects is one is move, then validate and capture. What is move? Move is used to change the position of that specific pawn or king or any other piece. Validate is used to check if the proposed movement by the player is valid or not. We are not getting into the internal details like what can be the parameters, what can be the return type. I will leave it to the viewer to explore that. Next is capture. So a player should be in a position to capture the piece of the other player. So all these are the behavior which is part of pawn or king or queen. The question is, will two different people or teams come up with the same number of objects, fields, behavior, class, and the relationship between them? Means the answer is may or may not be. But ensure that modularity, reusability, and other OOAD concepts are applied appropriately to come up with the best possible solution. Now let's get into the next step of the OOAD. That means we need to group all the related objects into a class. So if you go back and see, we had only one object of the chessboard. So, and we do not have any other similar object. So we can make chessboard itself as a class. Slot, there are 64 slots. So each S1 to S64, all objects are similar. So let us create a slot class for that. Then kings, there are two kings. One king is of one player, the other king is of the other player, right? So that can be a king class. So similarly, other classes, queen, bishop, rook, knight, pawn, all these are the other classes which we have come up based on the objects which are identified in the previous step. Next, we need to improvise this solution. So how can we improvise it? See, what is the relationship between the chessboard and the slot objects? That is the classes. Chessboard has a relationship with 64 objects of the slot class. So it has a relationship. It is composition because it is a strong relationship between chessboard and slot object, because the lifetime of both chessboard and slot objects is same. If it is different, then it will be a weaker relationship, which is aggregation. I would suggest you can explore more on the differences between composition and aggregation. Next, what is the relationship between the slot and the queen, king, bishop, rook, and other classes? The relationship has a relationship. Since it's a weak relationship, it can be considered as aggregation relationship. So if you take a slot class, you will have one data member to identify whether it is white or black slot, and you will also have queen or bishop or rook. As known, one slot can hold only one piece. So it can be either king or queen or bishop. It cannot be more than one. So how do you specify that? So what we need to do, we need to have a reference as king, queen, bishop, etc. And king need to be made null when there is a queen. And when there is a queen, so can it be improvised? Yes, it can be improvised by creating a common base class for all these pieces. So let us create a common base class and let us name it as piece. This is the common base class of king, queen, bishop, rook, pawn, knight. So the above design can be improvised by creating a common base class for all the pieces named piece. This piece can have all the common data in the behavior of various pieces. And you can make this as an abstract. That means the developer cannot create an object of it. And move, capture, check, etc. All these can be declared in this piece class. And let us override these methods in the derived class, that is king class or queen class or bishop class or whichever. Now, let us see the visual model for this software design. So we have a chessboard class. For simplicity, I have ignored the data members and the methods in the chessboard. I'm just trying to show the relationship between the classes here. So we have a chessboard. So the chessboard has a slot, not one slot. There are multiple slots, 64 slots. So what is the relationship between the chessboard and the slot class? We have already seen it is composition. So how do you show that in UML diagram? By using a filled diamond symbol. And what is this one dot dot star? This is called the cardinality. That means one chessboard can have any number of slots, or we can specify the exact number as 64. There is no chance that there can be more than 64 slots as a part of the chessboard. So we can specify one dot dot 64. Okay. Now let us see what is the relationship between the slot and the other classes which are identified. So we have a piece class. What is the relationship between a slot and piece? It is aggregation relationship. Both aggregation as well as composition, both are has a relationship, but composition is a strong relationship, whereas aggregation is a weak relationship. So why do we say that weak relationship means a piece object can be available even before the slot object, and so that is the reason it is considered as a weak relationship. And here we are specifying the cardinality is 1 dot dot 1. That means one slot can have only one piece. Now what is the relationship between the piece and pawn, king, queen, knight, and all other piece related class? It is inheritance relationship. So this is how we show the inheritance relationship. So to be more specific, this is hierarchical inheritance. That means there is a common base class, there are multiple derived classes. So this is the system design for the chess game software. Using this system design, you can create the software for this. Apply similar approach to perform system design of a given problem in your interview. Interviewer may not expect the ideal solution from you in a span of 15 to 20 minutes, but your approach and confidence matters a lot. So to build more confidence on you, you need to practice by taking some examples such as designing a blogging software, parking lot, e-commerce software system, etc. so that this will boost up confidence in you. Let us further improvise this design in the next video. Please subscribe to us and share it with your friends and colleagues, which will motivate me to come up with more such videos. And if you have any queries, feel free to post it in the comment. Thank you very much. See you in the next video.